Hi everyone, welcome to the webinar. I'm Lacey Butler, Product Marketing Manager. Today we're going to explore continuous everything, why you need mobile DevOps. I'm here with Keith Ballinger, Principal Program Group Manager, who will walk through how, with the right technology, processes, and mindset, any organization can ship the right app to the right customer at the right time. He'll close by answering audience questions. Please enter your questions throughout the webinar into the discussion box. And now, Keith will start the presentation.
Hello, and thank you for coming. We're going to be talking about continuous everything with mobile today, where we'll talk about why mobile DevOps is a huge advantage for your business, and then what is mobile DevOps, and how the various tools and technologies that Microsoft has for mobile developers can really help you build higher quality applications faster than you ever have before. So to begin with, I think it's worthwhile talking about a personal experience of mine with a mobile-first startup called Ravid that I worked on in 2009. Ravid was designed to make it easy to send video messages to your friends and family regardless of where they were. And it was in a time when existing solutions such as text messaging a video were very poor, but there was a lot of competition who was moving into this space. Now, when you think about the pipeline of how you build and ship an application, it starts with how you code. And agile development, things like Scrum and Sprint and XP, were all designed to help us as developers code more quickly. And one of the things I'm most proud of with the way we built Ravid is that we were very agile. It was great. We could code very, very quickly, even though we had a very small team. However, this pipeline wasn't agile across the board. We were very agile with the way we coded, but that didn't necessarily mean that we were speedy across the rest of what we did. Our rest of our pipeline was actually very slow. And the reasons for this is because while we could code very quickly and we got to a place where using continuous integration, we could actually build and run unit tests very quickly. But when it came time to actually truly test our application and truly make sure that what we built would run on our actual customers' devices, it was very slow and it was an intensive manual process. Now, at first, what we found was that maybe we can just speed it up by not manually testing. We have unit tests. That'll take care of it. So let's code very quickly, let's get our builds and unit tests out very quickly, and then we'll send it out to our customers, whether they would be beta users or actual App Store developers. But what we found is that that had a pretty bad impact on our quality, what our users thought of our application. We had way more one-star reviews than you would expect, and a lot of what we were being told by customers is that they were seeing regressions, or they were only seeing quality problems at certain times, maybe when other apps were running, maybe when they were on Wi-Fi versus various cellular networks. And this had a follow-on effect in that our active users slowly dropped. We were unable to keep users. We'd churn them out. Now, we could spend money on marketing to acquire new users. We could add more social features and invite type features to get more customers onto our app. But then every time they would leave, and the most common reason they left was application quality. But it didn't just end there. We also weren't able to learn about our customers. We weren't able to learn what features they actually needed and what features were actually important to them. So just for instance, we thought users would want to be able to send very long videos to their friends and families. Now, it turns out, in retrospect, people actually like to send very short video clips. They don't need to send 30, 60-minute long videos where they're just talking into the camera. But we couldn't learn that because we didn't have the kind of shipping cycle, which I'll talk about in a little bit here, where we could experiment with what kinds of videos and what lengths of videos and to how many people someone wanted to send. And our failure to learn meant that ultimately we were unable to succeed. So we needed to do something different. And our competition clearly did. They were faster than us, and they were smarter than us. And because of this, they were able to acquire users, and they were able to keep those users because they were able to fundamentally solve the actual problem the user had and build higher quality software than we were. So that begs the question, how do you solve this problem? How should we have solved this problem? Well, the answer actually is DevOps, and specifically mobile DevOps. So let's kind of dive into DevOps in a little bit more detail. One of the things that you will often hear, and is very true, is that DevOps is not just software. It is not just tooling that around based on automation. DevOps is as much about company culture. That is the how and why of where you build software as it is about the tools themselves. And if we dive into the culture, you'll see a lot of the business justification around DevOps and why it's so important. There's a famous thinker named Gene Kim who wrote a book called The Phoenix Project, where he talks about the 3 ways of DevOps. You can think of these as pillars of how you approach any kind of software solution from a DevOps mindset and why that is so important. So the first way, the first pillar that Gene Kim talks about is systems thinking. That is, we can't take something like our development pipeline and only think about and optimize each individual piece. I did that with Ravid. I optimized the way we coded. Ultimately, I optimized the way we did CI. We even really had a great and optimal solution for analytics that we built ourselves. But because we didn't optimize the system as a whole, and we didn't think about the system and optimizing it, we would just end up wasting effort on these individual silos. So at its core, it's very important that we think about our entire system end to end. Now, the second way that Gene Kim defined is about feedback loops. If you think about your pipeline of development, you have these various stages. And we now can consider them at a systems level. But in order for the system to be operating efficiently and for us to build the kind of high throughput delivery that we need to do, we need to make sure that each stage gives us feedback about the overall system, and then gives each prior phase automated feedback so that we can throttle what we're doing in an appropriate fashion. Now, if we have a great systems orientation, and if we have really great feedback built into our system, we can then achieve the third pillar of DevOps, which is validated learning. Now, what is validated learning? It's a very peculiar and specific phrase. Validated learning is about shipping the right thing to the right customer at the right time through experiments. Validated learning is about us truly being scientists and having a hypothesis and experimenting and then measuring what happened and then adjusting our course. And this is very important. Now let's unpack this statement overall. What does it mean to ship the right thing to the right customer? What does that word right really mean? Well, there are 3 basic attributes that we can reason on here. One is that just everything functioned correctly. There shouldn't be crashes. There shouldn't be exceptions that bubble up to the user in a message box. It should actually be a high quality solution that you're handing to users, and that it just works. You shouldn't have to click the button 3 times to make the button actually click. Now, if you have everything functioning correctly, it's still not necessarily right. You also have to be solving an actual problem that a user has. If no one needs your button or your feature or your 2-hour length videos that I can message from one person to another, we're going to be unable to actually say that we've shipped right software. Now finally, if we've built something that's high quality and functions correctly, if it actually solves a real user problem, finally, in order to be right, it actually has to be usable. That is, it has to be discoverable in the UX. It has to respond in reasonable time frames. It should be intuitive and not require specialized training to understand. Each of these attributes is ultimately necessary to feel like we're shipping the right thing to the right customer at the right time. Now, There's another piece to the statement, which is we actually are going to do this through experiments. As I said before, we need to think about ourselves as scientists, and sometimes as opposed to just engineers. We need to create hypotheses, what we think customers want. The hypothesis can really relate back to any of those three areas we talked about before. It can relate back to what we think is the right way to build something of high quality that will function correctly. It could relate back to, will this actually solve a user's problem? Or it could relate back to, I believe if we build the feature in this fashion, that it'll actually be usable and that most users will be able to walk through the entire workflow or discover the feature or whatever that is. So we need to create hypotheses that are very specific and that have a reasonable chance of being validated or invalidated. And then we need to code. And that's when we code an experiment to help us validate or invalidate that hypothesis. Then we need to deploy, and then we need to measure our experiment's success or failure. And this set of items we need to do as often and as fast as possible. We need to optimize this pipeline in order to be successful. And we can see that at play just comparing two companies. Let's imagine they're both building apps to purchase digital videos or something like that. We have company A and company B. And in over a 12-week time frame, company A does one release. Company B does 3 releases. They do less with each one, but they focus on experiments. And what's going to happen? Well, if we look at company A, they're going to have some amount of learning. Every 12 weeks, they could deploy some experiments, they could measure what customers have done, and then they will have learned something. Company B will also be doing the same thing, but because they're shipping more often, even if it's less each time, they're going to be able to kind of accumulate knowledge in a way that company A was unable to do. And we can see that as we compare the two. The amount of validated learning that one team has over the other truly becomes a competitive advantage in the meantime. I saw this with my first startup, with Ravid. We didn't know what customers actually wanted, and we didn't know what their actual problems were, and we learned about those things far too slowly. We also learned about the technical issues around cameras and sending videos over unreliable network conditions, again, far too slowly. Our competitors learned much more quickly than us. So even if we had a better product on the day we shipped than they did, because they could outperform us and because they could out-experiment us, they were able to ultimately win. So there's a set of syllogisms to think about here. I need continuous integration. And if I have that, then I can have continuous quality. And if I have continuous quality, I can have continuous deployment. And because I have all of these things, I can have validated learning. So really, what does it mean? Continuous delivery means that you can learn continuously and much faster than your competition can. Now going back to DevOps, this is really all about culture. This is about a way of building and running a product team. Thinking about experiments, thinking about hypotheses, thinking about optimizing your pipeline for continuous delivery. There is, however, an entire other side of the coin here, which is tooling. Tooling is what actually enables these cultural changes. Either you are going to build the tools yourself that let you be continuously deploying and therefore learning, or you're going to adopt tooling that helps you do this. And if you use those tools correctly, whether you build them or adopt them, you can get to a place where your pipeline is very full, and the bandwidth of how quickly you are coding, through building, through testing, through deploying, through learning is high bandwidth, and therefore you're able to do it so much more quickly than anybody else. But there are some challenges, some specific challenges for mobile developers that we really truly need to think about here, which is why we're talking about mobile DevOps today. One of those challenges is Android fragmentation. There are over 1,000 brands of Android devices at this point, and it's more than doubled over the past few years. And the number of combinations of brand and hardware and form factor and Android OS version is huge, and you could never actually test all of these things. This fragmentation is so large that one of the problems we had with Ravid is we would get these reports from customers. They would say things like, hey, I have the latest HTC phone. When I launch your app and I send a video, I see a blurry green screen, for instance. We got these reports so often that we couldn't possibly purchase enough devices to test manually or in an automatic fashion that we were actually solving all these problems. Now, we actually ended up going to the mall, to those kiosks, where T-Mobile and Sprint would be, and one of us would distract the salesperson while the other one would pretend to be checking out a phone. We'd go and download our app and reproduce bugs in that fashion. Now, thinking back to our pipeline, testing was already terrible and slow enough. If we're now having to go to the mall and distract a salesperson in order to validate a bug, you're just going to be going far too slow. Now, while Android is certainly very diverse, the iOS world is pretty diverse as well. There are multiple form factors, multiple popular versions of the operating systems, multiple ways that people can interact with your device, whether it be the Apple Pencil and 3D Touch and all these various ways. It's not as bad as, there's not as many combinations as in the Android world, but there's quite a few different things going on there. What these two challenges mean is that lots of mobile development teams are going to see quality as a very common constraint. They're going to learn to code and build very quickly, but when it comes time for quality, they're going to see these same issues. Now, what they need to do is have great functional testing. If you have great functional testing, you will be continuously learning because you can automate what your users are actually doing. Now, functional testing will give you great confidence. You can actually write a test that interacts with the UI in a way that a user would. But you need to be able to do that in a way that is quick. That's why manual testing ultimately doesn't lead to this great kind of DevOps world of continuous learning. And that's what Xamarin Test Cloud is designed for. Xamarin Test Cloud allows you to write automated tests that can be part of your pipeline that automatically execute after your CI build on thousands of devices. These are real-world devices in a lab with different operating systems and form factors available to you in many, many different types of models. If you add Xamarin Test Cloud or a similar real-world device automation to your pipeline, you no longer have to worry about quality being a constraint for your continuous learning. Instead, you have expanded your ability to test much more often, which means you can deploy much more often, which means you can learn much more often. Now, besides quality, another place where we need to be continuous is in our insight into what our users are doing, whether it is crashes they are seeing or their actual usage of our application. And this is what HockeyApp really helps us with. HockeyApp allows you to easily, again, as in an automated fashion from your CI system after your tests have ran, to deploy your application to beta users. And it also lets you see how those users are using it and your App Store users are using it, including crash reporting. You can get great, thorough analytics about the crashes and about what kind of devices are seeing crashes, along with stack traces that lets you easily find where those crashes are occurring. This is all part of that learning at the very end of the cycle. If you can create an experiment that you can validate by using HockeyApp's reporting, you'll be able to use numbers as opposed to just your gut feel or anecdotal evidence that you've actually solved the user's problem or not, or that you've actually resolved the crash across some form factor or operating system. HockeyApp, in the end, really lets you listen and learn from your users because, again, it helps you get the app out to them. It helps you see from all users, beta testers or not, what kind of crashes and errors they are seeing. And it also lets you collect that feedback. And you can collect that feedback, again, both from the analytics, like somebody pushed this button, somebody saw this kind of crash, but it also lets users give you feedback directly from the application in free-form text around how they feel about a new feature. So in the end, just to kind of sum up, the reason we want to be continuous with everything we do, the reason we want to be continually coding and building and testing and deploying and then watching and learning from our customers is so that we can have that competitive advantage where we are compounding what we've learned every day from our customers. With mobile, this is more important than ever because we have a much more difficult time deploying our software to mobile users. And not just deploying, there are so many different form factors in the mobile world. We have very special quality constraints that we need to take care of and worry about as well. And also, the way we can learn about a user, the types of analytics that are important in the mobile world are also very unique. But if we can combat these things and we can create a truly automated pipeline, we can be more successful than we ever have seen before. So now we'll take questions, and before we do that, if you want to learn more, go to xamarin.com/mobile-devops. Thank you very much.